Hi, I'm Shehryar Sardar, and this is my Physics 2211 Lab 2 Projectile Motion. Here's my table of contents with introduction, models, experiments, code, discussion, and conclusion. The purpose of this lab is to observe an object moving in a parabolic arc while being affected by gravity and drag, aka air resistance. We're also comparing the observed results to two computed models, one of motion under only gravity, and one under both gravity and drag. Fundamental physics principles. Newton's first law, the law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion unless affected by an outside force. An object moving experiencing no outside force will continue to move at a constant velocity. Newton's second law, acceleration of object is proportional to the net force it experiences, which simplifies to F equals ma. Models. First, we have our drag force equation, which is equal to negative b, the proportionality constant, times the magnitude of velocity squared, times the norm of velocity. Next, we have velocity and position update, where v is updated by the force divided by mass, and position is updated by velocity. Results preview. Here are three graphs, one of observed, one of gravity only, and one in drag plus gravity. Moving on to procedure, we need a ruler and object. We use an eraser as our system, a flat background and floor as surroundings, and a camera. Step 1. Measure the mass of the eraser. Step 2. Toss the eraser up into the white. And step 3. Record the eraser following a parabolic arc until it hits the ground. Next, we have data collection via tracker. In the left, you can see the image of the parabolic arc the eraser makes and when it hits the floor. On the right, you can see all the x and y positions for each time step. Next, let's get our initial values. For position, we just use the initial position in tracker. However, for velocity, we need to find the average in both the x and in the y direction. To do this, we just use the change in x and y in the first time step. To solve for the value of b, the proportionality constant, we had to experimentally test the code to find a final position that lines up with the observed. Next part of the code is the loop. First off, the final time comes from the tracker data. Next, we split up fnet into the fdrag and fgrav components. And then we update our velocity and position based off the delta t's. And lastly, we have an arrow for gravity, drag, and velocity, and we use the scaling for visibility purposes. Next, our results. On the left, you can see the trajectory of the object when it experiences drag and gravity. In the middle, you can see the visual representation of the ball with our gravity and drag arrows. And on the right shows us all the position in the x and y in both gravity and drag plus gravity. Moving on to our final results. The blue line shows the observed trajectory, the orange shows gravity only, and the green shows the drag. One similarity is the final position of drag and observed are close to each other, and one difference is that the height between drag and observed slightly varies due to average velocity not fully equaling the initial velocity. Some possible sources of error are poor computation, manual input, or poor visual tracking in the tracker. Now for some discussion questions. How is terminal velocity reached and was it reached in a model? Terminal velocity reached is when all the forces on an object in air cancel out. In ours, it was not, as drag did not equal gravity by the end. How can we reach terminal velocity? One way to do it is to drop an object straight down from a high enough height so it can reach terminal velocity before hitting the ground. If the object was thrown upwards with the same speed, how would it affect the time in the air? It would increase the time, since if we were at the same speed, which would be the magnitude velocity, it would have higher in the y, as some of the x velocity would be transferred into the y, increasing the speed upwards and time in the air. In conclusion, this lab showed how projectile motion functions and how drag is necessary to calculate accurate calculations for projectile motion. Thank you and have a good day.